Okay, geometry, here's part two. Part two of section 9-8. Now we're going to do the pyramid stuff. And so what I was trying to get at before the video cut out and the other one is that pyramids could have like a triangular bottom and then only 3 sides going up to the top. It could have a hexagon where it has 6 sides on the bottom going up. But what we're all used to, the one we're used to seeing is the one we're going to deal with. It's called a regular square base pyramid. All right, what that means is, and sometimes they just call it a square pyramid. All right, a square pyramid still has triangles going up to the top, but the bottom of it is a square. It's a square base is what they're talking about. So they'll call it a regular square base pyramid or a square pyramid. And I think you guys know what it looks like. So it has base is a square. That's just the bottom. The base is a square. Point at top is known as the vertex. Every corner is a vertex, but the top of the pyramid is known as the vertex of the pyramid, known as the vertex. It has 4 congruent isosceles. That's important. Triangles for sides to the top. All right, so let's draw what it looks like. We're going to have, what I usually do is draw an obtuse angle. So I draw this, and then I draw an obtuse angle like this. And that's the front edge and the right edge. And then what I do is, to give it that 3D perspective, I want it to look like it's slanted going up to the top. I picture where the midpoint would be on this front side, and I go a little bit closer to the angle, to the obtuse angle. And then I go up as tall as I want to make this pyramid. Put a dot. Now this is the vertex at the top. And what I'm going to do is connect here to here. And I'm going to connect here to here. And I'm going to connect here to here. Oh, missed my corner a little bit. All right. And just like the rectangular solid, and I should have done it with the square up here, we're going to draw what the back side of this looks like by using some dotted lines. And so what I usually do is I finish off the square on the bottom. It's going to look like a parallelogram. I'm going to go back a certain amount of ways and come across. And I don't want to hide this corner behind this line. It kind of messes it up. Then from there, dotted line up to the top. And there's my square base pyramid. Not perfect, but it's my square base pyramid in this diagram. All right, so there's 2 important parts to this. Well, actually, before I get to that, let's give it letters here. We'll call this A at the top. We'll go B in this back corner. Then we'll go C, D, and E. Just naming all my vertices here. A is known as the vertex at the top, the point at the top. I'm going to use a different kind of color in a second here. This is known as a lateral edge. Each one of these that go up to the top, they go from the base up to the top, DA, CA, BA, ED. That's a lateral edge. And then the ones that frame the square on the bottom, those are known as a base edge. All the base edges are the same. All the lateral edges are the same number. So if they give you a lateral edge, it's going to be the same. All right, now, there's 2 things that we need to find, and then we use Pythagorean theorem to get each one of them. There's something called an altitude that goes at the top, and it comes straight down to the middle of the square. And mine's a little off because my diagram's a little bit off. A, B, C, D, E, we'll call this F. So the altitude of the pyramid. All right. Sometimes it's known as the height of the pyramid. The altitude of the pyramid, also known as the height of the pyramid, is from the vertex top to dead center of the base of the square base, of the square base. So that's what I mean my diagram's a little off. Like if I were to draw the two diagonals and where they crisscross in the middle, that should be point F, exactly in the middle. So from the top coming straight down, AF is my altitude for this pyramid up above. AF is the altitude of the pyramid. And I need a different color, so I use that. Let's use this fluorescent kind of green. The other thing that we need to deal with is known as the slant height. The slant height is different than the actual height. The slant height is the perpendicular bisector of the side, I shouldn't just say side, of the lateral side triangles. Okay, so I can do it on any one of these, but the only place where it's really going to look clear is on this right side without interfering with other lines that we drew in. So what do I mean by perpendicular bisector? Picture where the midpoint is for this base edge here, and I can do it here, and I can do it here, and I can do it here. All right, it splits it in half. It's a bisector, but it's also perpendicular coming down. So it's going to make right angles like sideways, like a lean, and it's going to split that side in half. So I'm going to call it M for midpoint, AM. AM is the slant height. Oh, I'm sorry, I'm not getting it on the screen. AM is my slant height in this particular diagram. So you got base edges, lateral edges, slant height, altitude, or actual height in it. And the key to doing these problems, more times than not, is to really just connect F to M and make a standing up triangle in the middle, a right triangle that we could use Pythagorean theorem on. That usually is how we use pyramids with the Pythagorean theorem. I'll give you an example problem of that. Ran out of room here and move that over. So here's our example. Example 2. In a regular square base pyramid. All right, just letting you know the bottom, it's a pyramid shape and the bottom is a square. The perimeter of the base is 40 meters and the lateral edge is 13 meters. Find the length of the altitude and the slant height. And by the way, some of your homework problems or test problems, it might, instead of altitude, it might say the height of the pyramid. When you go from the very top of the pyramid straight down to the middle inside the pyramid, that's also the height. Height and altitude are the same. Height and slant height are two different things. So after you write this down, pause the video, take a minute, try to draw the diagram yourself. Try to draw the diagram and see what that would look like. Try to draw the diagram here. Probably easier said than done. Draw the diagram. So I'm going to go here, here, up, down, here, here, here. Yeah, not the greatest pyramid, but it's going to serve our purpose. What they gave us is that the perimeter of the base, well, the base is a square. If the perimeter is 40, then every one of these is 10. So this is 10, and that's 10. All right, and the two dotted ones, they're also 10. I'm not going to draw them in right now. The lateral edge being 13 are all these lines that go up to the top. So each one of those is 13. And I could draw it here, but I think it would interfere with my diagram. So we have two things that we have to find. We have to find the height from the top, all right, that altitude. And we have to find this number here, this slant height. And what you're going to do is make a triangle out of this. So what I like to tell kids is, say, picture it like you're peeling a sticker off. You're going to take one of these faces, one of these side triangles, one of these isosceles triangles on the side, like here. You're just going to peel it off. It'd be the front one, the side one. They're all the same. Peel it off, and you would have 13, 13, and 10. And when you draw the slant height in, it's a perpendicular bisector. So when you draw that in on the side, it's perpendicular, and it splits it in half. So that 10 becomes 5 and 5. And we're going to figure out, I'll call it S, we're going to find the slant height. So 5 squared plus S squared, that's S, not a 5, equals 13 squared, so I get 25. S squared, 169, I subtract. 144, this problem was set up nice. S is going to equal 12, so 12 goes here. Slant height equals 12. That's part one. We got the slant height using some of the clues that they gave us. Now, part two is, how do I find that pink line up and down the middle? I'm going to call that H for height inside. Well, the trick is, got to use a little bit of logic. This line that comes down from the top, this altitude, comes down and it hits dead center of the square. And so when I draw this line in across, it looks like this. And what it is that's 5. That's 5 right there. And so the triangle has a 5 and a 12. And this is H. That's the standing up triangle. I frame the whole thing for you. That's a standing up triangle inside the pyramid. So I go 5 squared plus H squared equals 12 squared. H squared is equal to, that's 25. That's 144. Subtract 25. I'm going to get 119. And when you square root that, I'm doing a little thinking here, but 119 is actually, I think it's prime. I don't believe 119 has an answer, or has a simpler answer. Square root of 119 is the answer. That is the answer to the whole problem. Kind of a weird number to come up with here. All right, so we got two answers. Slant height is equal to 12, and I would have gotten a half point off because I didn't put meters. I did say meters. And the altitude is equal to the square root of 119 meters. 119 meters. I don't know why I drew down there. It should be outside of that square root box. 119, square root of 119 meters. I don't think I said square root. Square root of 119 meters. All right, I'm losing my mind. Video's going on a little too long. That's the end of part 2. You got 2 examples, one of a box, one of a pyramid. I'm pretty sure your homework will involve like a cube shape. Just remember when they say cube that it's going to be squares instead of rectangles going all around. It takes a little practice with the drawings. Stick with it. Don't get frustrated. We all kind of laugh and giggle about how bad they look in the beginning until you get better at it. I'll try to help you in class. If you guys have any questions, please let me know. Thanks.